Hello, for this slide presentation, we will explain about type and use of male sterility. Male sterility. Male sterility is characterized by non-functional pollen grain, while female gamete function normally. Male sterility inability to produce or to release viable or functional pollen as a result of failure of formation or development of functional stamen, microsporus or gamete. The main reason of male sterility is mutation. There are three types of morphological of male sterility. Number 1. Pollen sterility, in which male sterile individuals differ from normal only in the absence or extreme scarcity of functional pollen grain. The most common and the only one that has played a major role in plant breeding. Number 2. Structural or staminal male sterility, in which male flower or stamen are malformed and non-functional or completely absent. Number 3. Functional male sterility, in which perfectly good and viable pollen is trapped in dehiscent, enter and thus prevented from functioning.
Genetic male sterility. Nuclear male sterility is ordinarily governed by a single recessive gene, MS, but dominant genes governing male sterility are also known in safflower. GMS occurs widely in plants and in given plant species. Several different MS genes act monogenically to produce male sterility. There are three types of genetic male sterility. Firstly, cytoplasmic male sterility. This type of male sterility is determined by the cytoplasm. CMS is the result of mutation in the mitochondrial genome, which leads to unfavorable nuclear mitochondrial interaction or incompatibility, the ultimate consequence of which of male sterility. In some plant species, such as barley, chloroplast genome has also been implicated in male sterility. Secondly, environment-sensitive genic male sterility influenced by environmental factors such as temperature-sensitive genetic male sterility. A high temperature leads to male sterility, while a low temperature leads to male fertility. Next, for photoperiod genetic male sterility, complete sterility is obtained in rice plants grown under a long day condition, but under short day condition, almost normal fertility is obtained. Then, transgenic genetic male sterility is occur due to mutation.
Next, the last type of genetic male sterility, which are chemical-induced male sterility, which is using chemical. Male sterility is induced by some chemical gametocyte. Other than that, male sterility is induced by treatment with male gametocyte and is non-heritable in nature. Next, type of chemical male gametocyte, which are ethyl, Ga3, malic hydrazide, NAA, natrium, and zinc metal arsenate. Lastly, ethidium bromide is the potent mutagen of plasma genes, which are petunia and barley male sterility. Use of male sterility, which are reduce the cost of hybrid seed production. Next, production of large scale of F1 seed. The performance is better compared to the parent. Other than that, it avoids enormous manual work of emasculation and pollination. Next, speed up the hybridization program. Other than that, commercial exploitation of hybrid vegan. For conclusion, natural male sterile mutant have appeared in the germplasm of the most used cultivar. However, their economic value was not recognized and there were less in few generations. Other than that, after the concept of heterosis, the benefit on the use of male sterility in hybrid seed production to increase crop yield were appreciated. Male sterility could be obtained by different failure in microsporogenesis, release of pollen grain, or pollen germination that do not affect the female reproductive system. Therefore, the male sterility plants can produce viable seed after manual pollination.